All right, welcome back everyone. Today we're going to be looking at polar form in the topic of complex numbers. We're going to explain what this is, and we're going to explain where it comes from as well. We'll spend a little bit of time of how we get to this form. So hopefully everybody is already familiar with what we call rectangular form. Maybe you've never heard it as rectangular form, but the way that we introduce complex numbers is we look at them in we'll call that coordinate form, x plus iy. We can plot them as a coordinate on a graph, x plus iy. That's what we're used to. We've been learning how to add, subtract, multiply, divide, talking about conjugates and all that type of stuff with rectangular form. But there's another way that we can talk about a complex number, and that is called polar form. So polar form, maybe you've seen it, maybe you haven't. This is what it looks like. We're going to explain where this comes from, but we write it as r cis theta is how we would say that word. And if you've watched the previous videos, we have already introduced the idea of r being the modulus and theta being the argument. So if you haven't already watched the videos about the modulus and argument, this will probably be useful for you before you watch this video. So polar form is when we write it in terms of the angle the angle theta and the distance r. So let's talk a little bit about what the heck this cis means and where do we actually get this idea of r cis theta. So let's say I have a complex number on my grid, on my Cartesian plane. We're going to pick a nice easy one to be somewhere up here, z. So here's my complex number z, and if we were thinking about Cartesian form, the one that the x plus iy, this would be my x, and this would be my yi over here. So let's say it was 3 plus 4i. This distance would be 3. This would be 4i, and that would be my complex number. Now I'm going to do what we've been doing recently and connect this to the origin, and I'm going to form my right-angled triangle here. So there is another way that we can think about this complex number. Instead of a coordinate, like going across and going up, we're going to instead think about it as an angle. So I could travel. You could tell me to start here at the positive real axis and tell me to travel some sort of angle. So where should I go? What angle should I travel in? And then once I've got the angle right, you'd need to tell me the length that I'll need to go along in that angle. So this is polar form. Instead of thinking about a coordinate, we think about an angle and a length that you travel. So let's try and explain where on earth this cis theta thing comes from, r cis theta. So let's draw my angle here, and let's label this length going up here my r. And we have our original form of this complex number as being x plus iy. So this distance across here, the whole distance, that would be x. If it was 4 plus 3i, this would be 4. And if it was 3i, this would be 3. But we're going to call this distance my y on my triangle. And now I'm going to do some SOHCAHTOA with my triangle real quick on a side note. So let's think about SOH, which in this case would be sine of my angle is equal to the opposite. So here's my angle, the opposite side would be y, and my hypotenuse side is r in this case. Now what I'm going to do with this real quick is I'm just going to make it so that it says y by itself. I'm going to take this divided by r and I'm going to multiply it up to this side. So this would be r times by sine of theta is equal to y. I'll put a little box around that. We're going to come back to this later. So in other words, this length y, this distance y, can be thought of in terms of the right-angled triangle and SOHCAHTOA as sine r times by sine of that angle would give me that length in a right-angled triangle. We can do the same thing with cos, and to get my x length. So cos of that angle, cos of this angle using the car rule is equal to the adjacent side, in that case is my x, divided by my hypotenuse, which is r, and I'm going to do the exact same trick, multiply that r to the cos, and write x is equal to r cos of theta. So again, that length x could be calculated in terms of a right-angled triangle using cos of the angle is equal to x over r and timesing by r, we end up with x equal to r cos theta. So it's another way to think about that length and that length. And now, if I write my complex number z equals x plus iy in a different format, I can change my x. That x and that x are the same. I'm going to change that to r cos theta, and I'm going to change that y to r sine theta. So this exact same complex number could be written as r cos theta plus I times by y, I r sine theta. And this, in its core essence, is polar form. This is essentially the polar form of this complex number z. Instead of knowing the coordinates of it, I can find that distance in terms of r and the angle, and I can find that height in terms of r and the angle as well, just using sines and coses. Now, so this is my coordinate system. If I did know something about the angle and the length, the hypotenuse of that triangle, I could also find the complex number using this. Now we abbreviate this down. Polar form, if you look back to what I wrote it over here, I wrote it as r cis theta, and this is not like that. It's r cos theta plus I r sine theta. We just abbreviate it. Mathematicians are lazy and don't want to write this out every time. And so what we do, we firstly factorize out the r. They both have an r, and I'm left with cos of theta plus I sine of theta. And then just the abbreviation, that cis thing is just my cos and my I sine. So we just abbreviate that to r, and then this cos plus I sine we're writing as cis, which is just an abbreviation. The C stands for the cos, the I is the I, and the S stands for sine, and that angle belongs to both the cos and the sine. So this is polar form. Now it turns out you don't need to remember any of this. This is just me explaining where on earth this r cis theta comes from. If you've watched the modulus and the argument videos, then it's very, very easy. We'll do one example. I'm actually going to pick a really easy example just to see it. If you want to see how you'd write r and angle of other complex numbers, go back and watch those other videos. So let's do one example. We want to convert, let's say, -2 plus 2i to polar form. And I am going to be using degrees today instead of radians, just to make our life so easy for this question. So convert -2 plus 2i to polar form. This is rectangular form. It's given to me as a coordinate. Let's go ahead and draw where this complex number is. -2 plus 2i, we're somewhere here. -2, and this is my 2i. So there's my complex number. As always, I'm going to connect that to the origin. I'm going to connect that to the real axis. Now, we have to be careful. If you go back and watch the argument video, the theta that we're actually concerned with is this angle here. This is my angle that I would like to write it in terms of, and my r is going to be this distance here. So we're just going to use some SHA.TeachMeMaths to help us find these two things. So we'll draw our triangle out again. Oh, that's bad. I was looking at the video, not looking at that. So this distance here is 2, and this distance here is also 2. I would like to find r. We're going to use Pythagoras' theorem. 2 squared plus 2 squared is equal to r squared. This is 4, so this is 8. And so r is equal to the square root of 8. That's my r. Now my angle, I'm not actually going to use SHA.TeachMeMaths for this one. I would usually get my triangle out, use SHA.TeachMeMaths, this being my angle here, x, and then I'd use that to help me find my actual angle. But I already know that if we travel the same distance across as we do up, we've gone 2 and 2, we've actually just cut this 90-degree angle in half. So thinking about this being a 90-degree angle, and we have cut it perfectly in half. You always cut it perfectly in half if you travel the same distance across and the same distance up. So I know that this angle right here is 45 degrees. And so the angle that I actually want is going to be 90 plus another 45. So my angle is 90 plus 45, which is 135 degrees. So my final answer, if I wanted to convert minus 2 plus 2i into polar form, it's going to be the square root of 8 cis of 135. So what we've actually said is that this complex number right here, if you started on this line here and you traveled a distance of 135 degrees, that would get you onto that line. And then I'm telling you to travel a distance of the square root of 8 in that direction, and you would end up at that complex number right here. Just to quickly recap, polar form we write as r cis theta, which actually stands for r cos theta plus ir sine theta, which is another way to think about where a complex number, or how to get to a complex number on our graph. Instead of going across and up, we can go an angle and a distance. To actually find it, all you need to do is plot your complex number, find the r, which in other words is called the modulus, and find the angle that it makes with the real axis, which is also called the argument. Hopefully this was helpful. Thanks for watching. Catch you guys later.